2.1 Curve Sketching and Approximations. Objectives: how are the slopes of a graph related to derivatives? So first we're going to talk about differentiability and continuity. So I say a function is not continuous. If a function is not continuous at x equals c, then it also is not differentiable. So for example, for this first part right here, if I had a function that has a break at x equals c, well, the function is not continuous, therefore it is not differentiable. I cannot find my derivative, I cannot find a slope at x equals c. However, it is possible for a function to be continuous and not differentiable. For example, if I have the function absolute value and say the vertex is at x equals 2, my function is not differentiable at x equals 2. But however, my function is continuous. There are no holes, there are no breaks. But because there is that sharp turn right here, there's a sharp turn, it is not differentiable. So, just as a note, you cannot differentiate a function at sharp turns. So, not differentiable, at sharp turns, and we're also not differentiable when our function has a vertical tangent line. So for example, if I had the function the cube root of x looks like this. So at this point right here, I would have a vertical tangent line, so it's not differentiable here. Okay, so how are slopes of graphs related to derivatives? So we've already found slopes of tangent lines using the limit process at a point, so given a point, and these are the derivatives at that point. So derivatives and the slopes of tangent lines, they are the same exact thing. So when I tell you to find the derivative, you are finding the slope of the tangent line. Okay, and we've done this analytically. Okay, using the limiting process, that is solving these analytically. Now I'm going to show you how to do it graphically. So graphically, the first step is to draw tangent lines on the graph so that we can look at their slopes, and then we're going to compare those slopes. So on that worksheet that I gave you today for like number 1, I can't really draw a tangent line to this because it's already linear. So what I want to do is I want to find the slope. So I pick 2 points that cross perfectly on the grid, and I see that the slope here is 2. And then I come up here, right here and right here, and I can tell right here that my slope is 2 there as well. And right here it's also 2, and right here it's also 2, and so on and so forth. So everywhere on this graph my slope is 2. So n equals 2 everywhere on this graph. So that's the slope, which is also the derivative, and I can graph the derivative. How do I graph f prime of x equals 2? Well, it's a horizontal line crossing at y equals 2. So this is the graph of my derivative. That's what I'm going to start doing now. I'm going to find my derivative looking at the slopes of the graph. So this is my derivative right here. And over here on number 3 from your worksheet that I gave you today, okay, if I start looking at my slopes here, slope there, tangent line there, tangent line here, right here. So I start looking at those tangent lines, and I see that from negative infinity to negative 1 in this interval right here, the slopes are negative. my slopes are all negative on this side. Remember, a negative slope looks like this. So all these slopes are negative right here. So that means that, and then from here to here is steeper than it is down here. So as it's getting further and further into negative infinity this direction, my slope is more and more negative. So more negative, less negative up here. So this, I'm graphing f prime now, f prime of x. Okay, on this other side right here, at the point where, on the vertex right here, my slope is actually 0. At that point. So that's my graph of my derivative is going to be 0 right here. It's going to cross 0. And then I start looking at this right-hand side from -1 to positive infinity, this side over here. I see that as I'm going further and further along to the right side, I see that my slopes are getting more and more positive. They're getting steeper. So more and more positive mean my graph is over here. So I just graphed f prime of x for this function as a straight line. So here are some general rules for graphing your derivative. F prime of x is your derivative. So a steeper slope means we have a bigger slope. And a positive slope looks like this. It rises from left to right. And a negative slope falls from left to right. A zero slope is a horizontal line. And an undefined slope is a vertical line. And this other note over here, in the case of negative slopes, a steeper slope is more negative, making it smaller. So in the first case over here, let's compare these lines and their slopes. So which line has a bigger slope, A or B? If you answered A, you are correct. The slope of A is bigger than B. Why? A is steeper. For number 2, which slope is bigger, A or B? If you answered B, B is bigger than A, you are correct. B has a positive slope, A has a slope of 0. The positive slope is bigger than a 0 slope. And number 3, which slope is bigger? If you answered B, you are correct. B is bigger than A. Why? Because A and B both have negative slopes. However, A has a steeper negative slope, which makes it more negative. So say this is like -2, where this one over here would be probably -1/2. So B is bigger than A. So let's look at more worksheet problems. Okay, so here on number 5 I have an absolute value function. Okay, and I said that we are not differentiable at sharp turns. So at x equals 1, it is not differentiable. So I do not have a slope there, differentiable. Okay, but I can take the slope of everything else. So the slope on the left-hand side, so from -infinity to +1, on that interval, I have a slope of -1, -1, -1, and it is consistent everywhere. So I have a slope of -1. So from negative infinity up to 1, I have a slope of -1. Okay. On the other side, I have a slope of 1/1, 1/1, 1/1 everywhere. So my slope is 1 everywhere. Okay, so from 1, from that sharp turn, from 1 to infinity, the slope is 1. And I draw those open holes because it is not differentiable at 1, at x equals 1. So number 8, we see that the slope everywhere on this graph They look like this, all my little slopes. So I can tell from this graph that all the slopes on the entire graph are going to be negative. So negative slopes all over. So I see that from negative infinity to 1 on this interval right here. It goes from very negative, because they're super steep here, very negative, not so negative, not so negative, not so negative. So very negative, very negative, very negative, very not so negative, not so negative, not so negative. And then on this side over here, I'm starting again at not so negative, more negative, more negative, more negative, more negative, very negative, very negative. So not so negative, more negative, more negative, more negative, more negative. So this is the slope of my, or this is the graph of my tangent of the derivative. So here are some more general rules. If f of x, if your function has a negative slope, then your derivative will be under the x-axis. If your function has a positive slope, then your derivative will be above the x-axis. And if your function has a minimum or maximum point, your function will be 0. Your derivative will be a 0 at that point. So like on number 8, from the previous example from the worksheet, we saw that it had nothing but negative slopes all over the place. That's why my derivative was under the x-axis. Now, had my point have been like number, let's see, number 7 right here. Okay, we see that all the slopes on this graph, they're all going to be positive. So positive slope there, positive slope, not so a smaller positive slope, bigger positive slope, bigger positive slope. So what we're seeing here is, here's my turning point right here. So I'll have my derivative function will look like this, because they're all positive. So it's all above the x-axis. And it's very positive, not so positive. So very positive, not so positive. It's close to 0. And then not that big, bigger. So not that big, bigger. That's why it looks like a parabola. Now on the last problem right here, I see that my slope is almost 0, then it starts getting more and more positive. Okay, so my derivative function is going to look just like it. That's my derivative, because it's not so positive, then it starts getting more and more positive. That's it. Here's an example from the homework. So the tangent line to the graph of y equals h of x at the point -1, 4 passes through to the point 3, 6. Find h of -1 and h prime of -1, so the derivative at -1. So h of -1 is easy. Go back to the point. What's the output? 4. Done with that. Okay, and then this one here, right here means the slope at x equals -1. So what does that mean? I'm just going to find the slope. M equals y2 minus y1 over x2 minus x1. Here's x1, y1, x2, y2. Put it in there. 6 minus 4 over 3 minus a -1 equals 2 over 4, which is 1/2. That's it. So h prime of -1 equals 1/2. Remember, derivative just means slope. Derivative is just your slope. Okay, bye.